What's the weight of 20? What's the weight of the 20 kilogram box? Remember? Think of how you calculate weight.
9.8 seconds per second times 20 kilogram.
So use the formula. W equals mg.
Yeah.
Now we know the m is 20 kilograms.
Yeah.
We know g is 9.8.
Yeah.
So just multiply the two together and get 196. 196 what?
Kilogram?
No. Weight is measured in?
M? Oh, mg.
No, it's newtons. Go back and check your notes, right?
Yeah.
Weight is measured in newtons.
Mm-hmm.
And we know that weight is going down, right?
Yes.
All right. Next question is asking you, what is the normal force acting on the 20 kilogram box here? Well, how do we do that? Well, we consider the fact that the box has the weight acting on it and it has a normal force acting on it, right?
Mm-hmm.
And as we did in our earlier examples, we know that the 20 kilogram box is not moving.
Yes.
Because it's not moving, that means its acceleration is 0. Now, the acceleration equals 0 means using, I mean, a lot of the time we just go straight to this, but I'm just trying to show you where we're getting these results from. Using F equals ma, where this F is the sum of the force. Because A equals 0, that means the sum of forces equals 0. Now, sum of force is the sum of all forces. And in this case, if I think of this as positive and this as negative, then in this situation, it will be N minus W. Does that make sense?
Yes.
So in other words, we're saying N minus W equals 0, which means N must equal W. Does that make sense?
Yes.
And therefore, in our situation here, your N must equal 196 newtons upwards. And this is 196 downwards. So, do you understand how we did this question so far?
Yes.
Good. So, calculating weight is easy.
Mm-hmm.
Normal means you do a bit of analysis. Think of the forces involved. Think of the acceleration of the object, if there is any. In our situation so far, there is none, which makes it easier. Use sum of forces equals ma, Newton's second law. Sum of forces can either be worked out using ma. In this case, that will be 0. But it's also n minus w in this situation. So we know those are equal. And that gives us n equals w, letting us work out n. Yeah?
Mm-hmm.
Now, of course, the questions can get more difficult. So here, we still have our 20 kilogram box. And now we've added a 10 kilogram box above it. Now, so this is where you need to start kind of breaking down the problem a little bit, all right?
Yes.
You need to draw a free body diagram. For each object that you are considering. So I'm going to consider the 20 kilogram object, and I'm going to consider the 10 kilogram object, all right? So there are two things here. One is the 20 kilogram object. One is the 10 kilogram object. So if you think of this as your 20 kilogram object, I want you to tell me, based on the information we've covered earlier in today's lesson, what are the forces acting on the 20 kilogram object? And I want you to try and be as specific as you can. So the 20 kilogram object has what forces acting on it?
10 kilogram object with gravity.
So there's weight, yes?
Yes.
So there's weight. Any other forces?
The 10 kilograms weight.
So I wouldn't call it weight, not here. As far as the 20 kilogram is concerned, it's just the force from the 10 kilogram. Does that make sense? Now that might equal the weight of the 10 kilogram, but here I'm not thinking of it as weight. Does that make sense?
Yes.
It's the force that the 10 kilogram box is giving me. All right. And therefore, what other forces are they acting on this? What other forces are acting on this 20 kilogram box?
That's it, I think.
No, because if those are all the forces acting on the 20 kilogram box, well, then it'd be going down, and it's not going down, right?
Oh, the normal forces.
Are there any other forces, or is this it?
That's it, I think.
All right, so I'm going to call it the normal force on the table. All right, 10 kilogram box. What forces act on the 10 kilogram box?
Weight
Correct.
and normal forces.
Where's the normal force from?
The 20 kilogram box.
Right, so you're right, it is a normal force, but I'm here just going to call it the force from the 20 kilogram box, yeah?
Yes.
All right, so these are indeed our free body diagrams. And when you do questions in this topic, it is absolutely critical that you draw these properly and identify every single force required. It might be fairly easy to you now, perhaps, maybe yes, maybe no. But it's important that you get your free body diagram correct. And your free body diagram must identify all forces, and I mean all, and no extra forces acting on that object. And you must also get the direction correct. Over here, we've only got up, down so far, so that's pretty easy, but certainly things can change and you can, you could have, and right now we've only got forces, normal and weight, but as we said, we could have other forces as well. So you need to understand every force very clearly, all right? All right. So then, that's just step one. So in terms of your general steps of solving a problem, obviously, I guess the very first initial step is to read the question and understand everything. But once you've done that, you need to, I guess, basically, essentially identify all forces required, all forces present, including magnitude if known. And direction. And that's the sort of based on the sort of tables and things that we've been doing earlier in today's class. And together, draw this a free body diagram. And this, it must incorporate all forces, including direction. So remember, your free body diagram is not to show you, the position of the object or anything like that. It's to show you the forces and the directions.
Yes.
Now, you know, if it's a 2D thing, we might need to break it up, decompose. I'm going to skip that for now. But basically, then you basically use F equals ma to solve the problem.
Yes.
So going back to our problem, we're now going to use F equals ma. So let's consider, for example, the 10 kilogram box, which is a bit easier. What's the weight of the 10 kilogram box?
10 kilogram times 9.8.
So it's 98. What unit?
Newtons.
Which direction?
Down.
Right. Now, is the 10 kilogram box moving?
No.
Right. Because A equals 0, so sum of F equals 0. So F 20 kilogram minus W must equal 0. In other words, the force from the 20 kilogram box is equal to W, which is what you were saying. And that's 98 newtons up. Does that make sense?
Yes.
Good. Now, if the force from the 20 kilogram box is 98 newtons up, what can you tell me about the force on the 20 kilogram box from, you know, from this? What can you tell me about this? From the 20 kilogram box's perspective, what can you tell me about F 10 kilogram?
Equal 98 newtons.
And why is that?
Cause that's a weight. 10 kilogram box is given.
I don't think that's a good answer. Why do you know that's 98?
I don't know them.
Think of what we talked about before. So F 20 kilograms is the force of the 20 kilogram box on the 10 kilogram box, yeah? F 10 kilograms is the force of the 10 kilogram box on the 20 kilogram box, right?
Yes.
So think about what we've talked about before and what sort of relationship is between those two forces.
Kilogram. That's a
So let's just replace it by A and B. So even a way, this is the force on A by B, yeah?
yeah.
This is a force on B by A, right?
Yeah.
What's the relationship between these two forces?
Same.
They are the opposite force, remember? Newton's
Yes.
third law. So therefore, we know for sure that this is 98 newtons down because these forces are opposite. Now, what's the weight force on the 20 kilogram box?
20 times 9.8.
Which gives you 166 newtons, yeah? So now we know the weight force and the forces going down, but is this 20 kilogram box moving?
20 kilogram box. No.
Is it moving? So its acceleration is 0. which means using Newton's second law, F equals ma, that means sum of F is 0, right?
Yes.
That means N minus W minus F 10 kilogram equals 0. So N must equal W plus F 10 kilogram, which is 196 plus 98, which is 294 newtons. Is that clear on how we did that?
Yes.
Good. So basically, you need to understand in general the different sort of types of ways that you can basically apply these. So remember, normal force is perpendicular. I mean, we're just focusing right now on these two. The other ones you will need to know, and as the question becomes more varied. But gravitational force always happens. The weight force you calculate by W equals mg, and it's downward.
Yes.
Normal force happens whenever you've got two surfaces in contact. It's always in the perpendicular direction, but we need to analyze the problem, including which way it's accelerating, if it's accelerating, and use F equals ma to work out the normal force. And this over here is an example of how we've done that.
Yes.
Questions can and do get more involved as time goes on, but you just now basically need to follow and practice the steps we're talking about here. Make sure you read the question and understand what it's talking about. Very fundamental and basic, but you'd be surprised how many people don't do that. Think of what we've talked about. Identify all the forces that you need to consider. Right now, we're focusing on weight and normal, but that will it will expand. And then draw your free body diagram indicating every single force acting on the object, and including the direction. Right now, it's only 1D, so we don't need to worry about decomposition just yet. And then use F equals ma to basically sort of analyze it. And that is exactly how you would basically do every single type of question in this topic.
Okay.
We will be spending quite some time over the next few weeks doing multiple questions on this topic and introducing concepts as we go. But the fundamental laws and how we do it doesn't change. What only changes is how many forces are present, the direction of those forces, and maybe we introduce friction and all, but the idea is still the same.
Yes.
Got it?
Yes.
Great.